I'm going to do cross-country regression. So you want to leave the room, this is a good time. I'm going to talk about weather, climate and total effect of productivity. This is joint work with Marco Letta, who's actually done most of the work, and I'm just standing here like John Terry. So you may have seen variants of this picture. What we're looking at here are estimates of the static impact of climate change. That is, how bad would the average person feel if climate were to change by, and that's displayed on the horizontal axis, where climate change is indexed as the change in the global mean surface air temperature, and then on the vertical axis you're looking at the welfare equivalent income loss. So the way to read this graph is that if the world were to warm by 2.5 degrees and nothing else would change, then the average person would feel as if she had lost 1.3% of her income. So this is not a change in economic activity, but this is a welfare change, right? And there's been a bunch of these estimates, and the picture that you see emerging is twofold. One, mild warming is probably net beneficial, but that is up to 1 degree or so, and you're there already. What really matters is what comes after, and that is probably a net damage to welfare. But the order of magnitude is smallest, right? We're talking about a century of climate change doing as much damage as losing 1 year of economic growth. And if you're very pessimistic and you focus on the lower bound of the confidence interval, then perhaps we're talking about a lost decade because of a century of climate change. And that is just not a very big number. And some people are upset about this number just not being bigger, right? And these are empirical estimates. One immediate objection to the estimates that you see here is that they're comparative statics. We just compare one situation to the other. There's no knock-on effects or anything. This is just pure static impacts of climate change. So some people have worked on the impacts of climate change on economic growth, and you're looking here at some results that I did at St. Frankhouse. I published with St. Frankhouse now 11 years ago. And the bottom line that you're looking at here are the assumed static impacts, and then the lines that you see above that are what happens to economic growth, what happens to comparative steadily to the income in the future if we stick this in two old growth models, that is the Solo model and the Ramsey model, and two new growth models, that is Mankief and Romer. And what you see is that those static impacts that I showed are roughly equal to the dynamic impacts according to 3 of the 4 models, and perhaps the dynamic impacts are twice as high in the Mankief-Romer model. So comparable order of magnitude, but of course it immediately implies that the numbers that I showed previously are underestimated by 100 to 200%, right? But for today's story, this picture is actually the more important one, and that is if we stick the impacts of climate change into these growth models, then this is the scenario, the assumed economic growth scenario without climate change, and this is with climate change. So the story is that climate change will slow down economic growth, but not reverse it. That is the story that emerges here. And the channels through which climate change affects economic growth in these models are through productivity, labor productivity, capital productivity, depreciation. If you have a big storm, then it washes away your roads and your bridges and your buildings. And if you have more of these, essentially capital depreciates faster. You have labor productivity. If people get malaria or something like that, they don't work as hard. And there's just all sorts of disruptions. And if we stick those factors into these growth models, we find substantial effects, but not ones that would change the view that we have of economic growth, would essentially just slow down economic growth a little bit. And the impacts of climate change are still fairly small, and therefore to some people upsetting. But somewhere in the back of our minds there is this picture, where we know that if we look at the distribution of income across the planet, then we find that the poor people tend to be near the equator and the rich people tend to be far away from the equator. There is a clear correlation between heat and income. And of course, there's been a long discussion about whether this is causal. In 1997, Jared Diamond sort of revived the spirit of Huntington and argued in, I forget the title of the book, not the second one, but the first one, Guns, Germs and Steel, yes, argued that geography is the fundamental cause of long-run development. Sort of environmental determinism revived. People in Papua are poor because they are in a tropical climate. It's essentially his thesis. Often overlooked, there's actually a paper in the European Economic Review in 2005 that redoes Diamond, but now econometrically, and find at first sight credible support for this. But of course, in economic circles, this environmental determinism is mainly associated with Jeff Sachs. And I list here one paper, and Sachs doesn't say that geography is the only thing that matters, but he definitely makes the point that geography is very, very important. Some people got a bit riled by that, and there is a series of papers also listed here that say that definitely now, but probably over the course of history, institutions are the only thing that matters. What matters for humans is other humans rather than the environment. And that seems to be the prevailing view amongst economists at the moment. But there are two recent papers, one by Marcella Alzon in the AER last year, where she looked at the effect of the Cheche fly and presents what I think is credible econometric evidence that yes, the Cheche fly significantly holds back, statistically significantly, but also economically meaningful, holds back development in sub-Saharan Africa. And there's another paper in the JPE, not sure that it has been published, but it will be out soon if it hasn't, where Barnabek-Anderson argues, no, this is wrong. It's not climate per se, it's not temperature or rainfall, but it's really UV radiation, which is also stronger, closer to the equator, that is holding people back. So there is a bit of a revival of this. Geography should not be discounted as an effect on economic development. This is a bit of background. Partly in response to this discussion, there's been a series of papers where people look at the effect of weather, climate, and geography on economic activity directly, rather than the big pattern of development or on economic growth. And Eric Strobel probably should take the credit for starting this. Their Restart paper of 2010 argues that the decline in rainfall in sub-Saharan Africa is partly to explain, partly explains the sluggish economic growth in Africa, sub-Saharan Africa. And then there's a whole range of more recent papers by Burke and Ishang particularly, but also a paper by Melissa Dell of MIT, where they look at the effects of weather variations on economic growth. Two problems with this literature. One, they don't study climate. Climate is the 30-year weather average, sort of the long-term background. Weather is what happens day to day. They focus on weather. Climate changes only very slowly, so you never have the economic data, apart from cross-country regressions, to look at the effects of climate. But if you just study a country like the US, you have lots of weather variations going on all the time, and you can immediately study the effects of weather variations on economic activity and economic growth, and that is what this literature does. Problem is, of course, that you then estimate the short-term elasticity, but you're interested in the long-term elasticity, you're interested in the effect of climate. So extrapolation from weather to climate is just very, very difficult. So that's one problem with this literature. Another problem with this literature is that their estimates are all over the place. If you just compare the effect size from one study to the next, you find very different results. And that is what is illustrated here. To your left is a beautiful graph that is complete hogwash as far as I understand. This was published last year by Marshall Burke and colleagues in Nature, of all places. That is where you would take an economics paper nowadays. And what they show is scenarios of economic growth without climate change, in grey moving to the right, and then for the same starting points moving to the left, scenarios of economic growth with climate change. And what their econometric model suggests is that a significant part of the world would see a reversal of economic growth because of climate change. That is what their paper says. And if you say such things, you get published in Nature. On the right-hand side, you're looking at the results that Melissa Dell and colleagues published in the American Economic Journal, where we're also looking at the effects of climate change on economic growth. For rich countries, here is the zero line, and what you see is that they found no effect, no significant effect of climate on economic growth. But for poor countries, you find a significant effect that is looks big, right? Because here we're talking about percentages. Here is 0, this is 5%, this is 10%, minus 5, minus 10, of course. And then on this axis, we're looking at changes in the temperature. This is sort of medium-term weather variation. This is not climate change. This is the annual. This is the change. This is the annual economic growth, and this is the change in temperature over 15 years. The projected warming over this century is about 3 degrees, which means that the warming per year is on average 0.03 degrees Celsius per year. So really, the relevant parameter estimates are here, right? They're not here, where the effects are sort of approaching 5, 6, 7%. The relevant effect size is here.
So in this one, what's the time span of this change in temperature and change in growth?
75 to 90, and then 90 to 2005. 1975 to 1990 versus 1990 to 2005.
So it's just one change in temperature on one change in growth?
Yes.
Over
long,
25, 30 years or whatever?
Long differences. Cross-country regression on long differences is achieved. The important thing is that Dell's effect size is much, much smaller than Burke's effect size, right? So that is where the empirical literature is. There's also an analytical literature, and it's been recently hypothesized, sort of thinking back of the Fankhauser and Toll paper, where the effects of climate change on economic growth were not very big. Some people have said, but what if climate change affects total factor productivity directly? And we, of course, know from Solo's work that the main driver of economic growth is changes in total factor productivity, right? So if there is somehow a direct channel of climate change on total factor productivity, then we could expect much bigger effects on economic growth from climate change. And there's 5, 6 papers in the literature that says this. And this is one of them in a top legal journal, because that's where you take economics papers. And this is the scenario without climate change, GDP per capita. And then here, what happens if climate change affects total factor productivity directly, then indeed you see a reversal of economic growth. In the longer future, apart from this scenario where it could actually happen this century during the lifetimes of some of you. So if this is true, it is important, right? It's potentially very important effect. It of course also changes your discounting and so on and so forth, right? at this point, the second part of your Ramsey rate would go negative, right? You would start putting more weight on the future rather than less weight. Peter?
I'm sorry if this is a dumb question, but how can you distinguish between the effect of climate change identified on TFP rather than on growth?
You can't. I would not know how to do it. Maybe you can, but I would not know how to do it. Just putting up the old picture again to show the contrast, right? So, what are we doing, or rather, what is Marco doing with a little bit of help of me? The thesis is simple, right? If climate change would affect total effective productivity growth, then climate change is a much bigger problem than we have previously thought it to be. Does climate change affect total effective productivity growth? Right? It's a simple question. Not sure that the answer is that. So what did we do? Went to the Penn World Tables. 60 countries, 47 years. And the late...
So I thought you might get this point maybe to the 6 or 8 papers you mentioned, will they discuss the mechanisms? Is the effect flowing
No.
damage to capital and human capital, or it's independent, also on other independent mechanisms here?
Let's assume is what they do. There is no real discussion of the mechanisms, particularly in the main paper by Dietz and Stern. It's essentially, let's assume that climate change affects total effective productivity. What happens? That's what the paper does. Yeah, I had a discussion with the editor about it.
And this is exactly what I was worried about. I mean, in some sense, if you start to say, well, the mechanisms of climate change act differently on labour productivity because if it gets hot, people can't work so hard. It acts differently on capital because you get exogenous shocks to smashing, with tsunamis you smash up ports or you smash up power plants or whatever. But in some sense, you know, by definition, this is the residual. It's more to do with technical progress. Okay, so what seems very crucial here is the mechanisms and
yes,
being able to say, okay,
that's the next slide.
Okay, right.
That's the next slide. And the defense of the paper is very simple, right? There are 3 prominent papers: Top Legal Journal, Economic Journal, Nature Climate Change, that posit this. Right? There's no evidence presented in these papers, but they got published nonetheless. We present evidence. That's the selling point of the paper, right? The latest edition of the Penn World Tables has data on total effective productivity. Data on total effective productivity. Of course, total effective productivity is not observed in sort of conceptual terms, analytical terms. Total effective productivity is the solar residual, right? That is that part of production of outputs that you can't explain by capital and labor and intermediates. In econometric terms, it's of course the intercept, right? That remains if you do a translog. And in this case, it's Feenstra who did it, or Feenstra's RAs probably. They did a translog on capital, labor, and materials, intermediates, essentially. That is what they did. And then TFP falls out. Something's wrong with that TFP data. It's their fault, right? Not ours. We just took their data. What is the problem with this? And Peter started talking about it. We don't need to worry about reverse causation. I don't think we should worry too much about confounders, but of course we haven't got a clue about the mechanism, right? Total effective productivity is and particularly change in total effective productivity is sort of a catch-all for genuine technological progress. It can be managerial change, it can be behavioral change. We're measuring at the macro level, so it can be a change in the structure of the economy. Within sectors, it can be entry and exit of particular companies. May also be changes in regulations, taxation, what have you, right? None of that stuff can be done with the data that we have. If you want to do this, there's presumably follow-up papers, but we can't do this at this level with this data, right? So don't shoot me for this because I am aware of it. Okay?
So the no prospect
No
for
stopping you
reverse
anyway.
cau-
Right? Sorry.
No prospect for reverse causality is because you're thinking at individual country level.
Oh yeah. And I mean the lags in the climate system and so on and so forth. That a change in economic output today, yes, would change your emissions today, but it would not change the climate for another few decades. Right?
No, but anticipating climate change, when you start investing differently, and that changes the PFP. So that's
Yeah, but we know the size of these investments and they're very tiny. So yeah, theoretically yes, practically no.
So these solar residuals, are they estimated with different parameters on the production assumption for each country, or is it a common thing? And if climate change affects the true parameters, is this going to complicate?
That's a fair point. I've read the Feenstra paper on this a couple of times now. He doesn't say what he actually did. The paper is very obscure, and at the end the data just roll out, right? But what happened?
But the raw data is available. You could figure it out, right? You could do it.
Yeah, we haven't yet. Maybe we should.
But I mean that's
But no, I see your point, Sam. I see your point. That if they misspecified their equation, not taking into account what we did, then we have a problem. Yes.
so. I mean, Sam's point, you're thinking about that sort of.
Don't do that.
You're thinking about sort of random coefficient plots, like that, where technology would determine for some countries near the equator, there would be a different technology going into this reduction.
Right, so maybe the depreciation rate would be different, for example, or whatever.
Yeah. No, I mean, we don't observe the capital stock either, right? That's based on some sort of inventory model derived from the investment, which you do observe.
So
So
there must
that
be a
could-
different
They
depreciation.
must make assumptions about depreciation, yes. No, that's a fair point.
But the raw data is available, right, going back for quite a number of years.
Yes.
Right. So in some sense, you don't have to just take the TFP. You could take all of the changes in all of the factors, and it's not going to be causal, but just in terms of descriptive statistics, say something about, is it the case that climate change is more affected by, say, labour productivity than something else? I mean, just descriptively, it would be interesting to know if the countries that are suffering the most change in their climate, it's potentially more to do with labour, and actually tease out some of this potential difference in technology as a result of being near the equator or not on each of the components of growth.
Oh, that's fair. That can be done, yeah. That's one way of doing it. The other way would be to decompose the changes in TFP into it. Need to think about this, but it's definitely possible.
Richard, you may not understand fully how these are calculated, but there presumably some price element in here and some exchange rate element as well. In the dependent variable of these regressions, I guess.
Yes.
And they may be moving across countries and time in response to, I mean, you might still say that's a good thing, but
TFP is the solar residual, right? It is the change in TFP is the change in total output that cannot be explained by changes in capital, by changes in labor, or by changes in intermediates. I put these dots here because when I wrote this slide, I wasn't quite sure what to do with international trade or international price movements, knowing that Alan would be in the room, suspecting that Alan would be in the room. I put it on the dots here. I'm not sure whether it falls here or whether it falls. It's a separate thing.
But these have been measured ostensibly, they've been measured at a constant versus now parity.
Yes,
That's
yes.
like combinations of them will take get everything.
Yes.
So in a sense, the problem is whether the periodic rebasing of the it has some sort of systematic element.
Yes. No, there is a long list of things going on behind your TFP measure. The hypothesis is that this thing is affected by climate change, and the question is it? So let's move on. Talked about the TFP data. We take weather data from University of Delaware, and we just borrow Melissa's work, where she aggregated these things to country year level using population weights. So this is the average weather experience by a person, and then in some of the stuff we also use GDP per capita data from the Medicine Project. Some descriptive statistics. The average TFP growth rate is 0.5% a year. Enormous variations. Max is 27%. Ireland isn't in here, or the recent upgrade of Irish GDP isn't in here, right? It had everything to do with an airline leasing company shifting stock from one place to another. That is not in here, but that would have a similar effect, right? Nothing going on, but all of a sudden your GDP jumps. The minus 56 that you see here, actually forget, it's either Iran or Iraq in the first year of the Iraq war. I think it was Iraq. So enormous variation there. Average temperature increase is 100 of a degree Celsius per year. Variation is quite big, right? You see enormous variations in temperatures from one year to the next.
So what kind of country, the 2.4 country, what kind of, the country that's getting hotter by 2.5 degrees a year?
Not a year, this is in any year. Right. It's not an average, that would be quite astounding. So quite a large variation there as well. Nothing much to say about the empirical strategy, right? So we take the annual growth rate of TFP, so we log and then the difference. We rest that on the constant on the temperature, on the precipitation, and then we use country fixed effects, time fixed effects, so we just kill the background pattern by dummies, essentially. And we just look at the effects of temperature and precipitation, right? Plus the standard errors. Yeah.
So now this would again be going back to looking at how weather affects your total technical
Yes.
activity.
I'll get back to climate hopefully at the end.
So what are the regions here? So you have a cluster of regions, being states or?
Regions are North America, Sub-Saharan Africa, those sort of things. We played around with.
So you have counter specific trends
In principle, we also try that. Doesn't make a big difference. Essentially, what we do here, the basic specification that you see here is essentially Melissa Dell's specification, right? But then we did try country trends. We did do different regionalizations and try to victim it out. It all doesn't matter for the basic results. What do we find? I hope this is visible. I always giving out to people about putting up slides that are not readable in the back, right? So we can get back up on that. So this is basic specification, temperature and precipitation, no interactive dummies with anything. What you find is that if it is 1 degree, or if the temperature goes up within a year by 1 degree, then total factor productivity falls by, growth falls by 0.5%. Right, so that is how you should read the number. It's significant, right? Then what we did was we did 2 interactive ones. Here we interact, the factor in the precipitation is not significant. We interacted temperature with a dummy for being poor in 1965, that is being below the median in 1965. Then the main effect disappears when the interactive one appears. The total effect in poor countries is a drop in total effective productivity growth of 1.5% per degree warming, right? And in rich countries, there is no significant effect. This is what Dell found as well, right? If we interacted with being hot, that is being on average warmer than the median, on average over time, the median over space, then we do not find a significant rate. Now I'm reading this wrong. If we, I should say this like this, if you confront poverty or contrast poverty with background climate, poverty wins, right? So the fact that you're vulnerable to weather variations has nothing to do with your background climate, but it's everything to do with your level of development, right? That is how you should read this. And then we tried alternative definitions where it's not in 65 or across the whole panel, and the same here. Similar results pop up. The effects are relatively robust: 1.5%, 1.1%, 1.3%, 1.3%, 1.5%. Right? So numerically, the effect size is roughly the same, and it's always concentrated in what, as far as we can see, in poor countries rather than in hot countries. Yes.
So wouldn't it make more sense to do this in levels, given that you're interested in the effect of warming, not the effect of cooling relative to last year? So your differences can be negative, would be negative, but
yes.
very hot last year. Right? So this is the critique that's showing critique of Ted McGill's famous conflict and
Yes.
rainfall paper, and it seems like the same thing would apply here.
It doesn't. We did try the specification with negative shocks and positive shocks have separate coefficients. Same result pop up.
What about poor and hot interaction?
We don't have the data for that, I don't think. It's worth trying, but I don't think we have the data for that. And I'll actually, the slide after next, I'm going to talk a bit more about it.
Richard, sorry, maybe this might be not known in detail, but is it? So would you have expected these negative coefficients on the interaction time? So something there seems to be some sort of ability between them. Is it not?
I mean, this is. I mean, if you think about, say, the structure of the economy, right? I mean, the UK economy is driven by finance, right?
No,
Are we susceptible to weather and climate? Probably no. If you think about a country like South Sudan, extremely poor, 90%, 95% subsistence agriculture, weather is terribly important, right, for them. Much less for us. We like to talk about it, but it doesn't really affect us.
But it's also the case that we know that the effects of natural disasters are huge, much more significant in poor countries rather
Yes.
than rich countries. So you have many fewer insulating strategies.
Exactly. So yeah, this is what we would expect, right? The question is it poverty or climate that drives
I
vulnerability?
may have asked you this in your last talk, and I don't know if this was stated, but is this an issue of an increase in the number of or frequency of extreme events, and that's what's driving this? It's just the distribution of weather. If you take a day, which just shifts by half a degree or something, and everything else. It's not more unpredictable. It's just a simple level shift. What's going on here? What drives these things? Is my paper that should doing robustness stuff to see what's.
Dell does not, but Strobel and His Young do. And they look at natural disasters separately and find similar things that, yes, they affect economic growth in the short run as well as in the long run, and that the effects are particularly pronounced in poorer countries.
And warming increases the frequency of.
No, it does not.
Okay, so then-
Warming does increase the frequency of heat waves, but not of floods or droughts or hurricanes, for that matter. So this is not that, right? This is just temperature, and of course, a little bit of change in temperature should not affect your total effective productivity as much. So there's also some sort of packaging going on there that we haven't unpacked, right? So we reran this thing on a sample of poor countries only, very similar effects, goes up to 1.8%. Then the problem with the sample starting in 65 is that there's only a handful of countries that are the problem in the original sample is that most of the poor countries are also hot countries. And there's only 3 or so exceptions there, Singapore for instance. And so we restricted the sample to start at 1970, and then we add countries like Bulgaria, Hungary, Kuwait, right, hot and rich, Saudi, hot and rich, Qatar, hot and rich. And we have a bit more power in the distinction between being hot and being poor. It does not really affect the qualitative pattern, or for that matter, the quantitative pattern. We're still talking about 1.1 to 1.3% change that is concentrated in poor countries, does not seem to pop up in hot countries, right? So restricted the sample size, but observe more of the pertinent countries here. Results are roughly the same. What else did we do? We changed the temperature data. So instead of using University of Delaware, we use University of East Anglia. So that is one change, and the other change is that we moved away from population-weighted temperatures to area-weighted temperatures. We can't do both. We can't do separate these two steps. But the effect is the same, right? Still, climate effects, TFP, or weather effects, TFP growth, and the order of magnitude is 1.3% or so in rich countries, in poor countries, sorry. That is what then I'm going to get to. Anyway.
Following up on Victor's question, so this rainfall measure and this difference in rainfall, how exactly is this measured for one country? So in one country, you're measuring daily rainfall in 500 different locations. So how do I come to that yearly measure exactly?
Well, exactly is a long question.
Well, okay, but is it the aggregate?
Roughly.
Are we talking about total rainfall in the capital?
So,
One year comparing with the total rainfall in the capital in the next year? What is, the reason I'm asking is
go
because
ahead.
a lot of these countries are dependent on agriculture, so how the links, as we know, between agriculture and rainfall are crucial, and it's not always about total rainfall, it's a lot about distribution and pattern. So I'm just wondering how much this measure can capture that, and if it's not capturing it, we might be underestimating it with whatever relationship you want to estimate.
So, I know the University of East Anglia much better than the University of Delaware, and I know roughly what they do, right? But it's a very long answer, right? And there's hundreds, if not thousands, of papers on exactly this question. So you measure temperature, you measure precipitation in certain locations, right? And what you need is a comprehensive area covering geographically explicit rainfall pattern. So the simple way of doing it is to use simple statistical interpolation. The correct way of doing this, but that is not what is done here, is to use a physical model of rainfall. You use essentially the model that we use to predict the weather. Run that model and make sure that at the places where you have measurements, where the times where you have measurements, you exactly, or as close as you can get to the data, and the rest is filled in by the model. And that would be physically plausible weather. But of course not observed, right? What they do in East Anglia is a mix of the two. So essentially they run a regression and use the regression to fill in the gaps. And the regression has such things as mountains in, right? So the orography is there, but not much else. So you get something that is not quite physically possible, but reasonably good, and it sort of gets close to where you are. And then you have the rainfall in all parts of the country, and then you need to take the average of that. Right? So the fact that they use the area weighted is, of course, also important. If you take a country like Mali, for instance, which has this huge desert in the north where nobody lives, right, and all the people are concentrated in the south, population weighted versus area weighted makes a big difference. Right? And it's not just that there's no people there, there's also no agriculture there. Right? Okay. I'm running out of time. So, what do we find? 1% temperature shock, weather shock reduces TFP growth by approximately 1.1 to 1.5%, but only in poor countries. This is perfectly consistent with what Melissa Dell found and published 4 years ago. Of course, C did not have the total effective productivity, so C looked at per capita income. And it is in sharp contrast with the findings that Marshall Burke published last year in Nature. How do we take this to climate, right? We've been talking about weather so far. So the standard deviation, if you recall the descriptive statistics of temperature, annual variation is about 0.6 degrees Celsius per year. The projected warming over the century is 3 degrees, maybe 4 degrees. If you work hard, maybe 2 degrees. So the trend is actually fairly small relative to the annual variation, right? So we're not extrapolating too much, I think. So essentially what happens in climate change is that you still have the interannual variability, but what you now have is that the positive temperature shocks, the positive weather shocks, are either slightly more likely or slightly bigger than they used to be, right? That is how the trend will manifest itself. And that is what we essentially done. We just integrated over those things, and we impose a slightly, we just make positive shocks slightly more likely. And then we apply the estimated short-run semi-elasticity, the semi-log model, to the trend of 0.3 degrees a year. And of course we use the estimated short-term semi-elasticity, so we presumably overestimate the true effect. And if we do this, then what do we find is that depending on this climate change scenario we assume, we reduce TFP growth by 100 to 1/10 of a degree per year, right? So this is economically meaningful, right, because it's cumulative interest, right? Over a century this makes a large difference at the end of the century in total economic output and per capita income. But of course this does not reverse economic growth in the slightest, right? Happens in poor countries only. And of course the selling point is that this essentially undermines the Dietz Stern paper published in honor of Bill Nordhaus. I'm sure that it was something to do. Last year in the Economic Journal, we just said, oh, this is a big thing. And we find statistically significant, but perhaps economically not that meaningful. That's all I wanted to say.
Thank you.
On time.
The characterization of things at national level, I mean, looking at the total amount of rain across the whole of the US this year compared to the total amount of rain across the whole of the US last year, and seeing whether there's some correlation between that and change in US GDP. Is that an interesting thing to do? I mean,
well, this should not be the last word, obviously, right? So Hishang is now moving towards, indeed, state and county level data in the US, where this is feasible. Of course, the problem with the US is that institutional variation is not that great, right? Climate variation is large, but of course smaller than the world as a whole, so you look in a particular spot where you happen to have good data, right? It would be cool if you could do this with microdata, either at the company level, preferably not just for the US, but also for a country like India. What Marco is doing, this is the first paper of his thesis, what he's doing for the second paper, finding actually remarkably consistent results with this, and I find that remarkable because it is completely different, where he does it for households in Tanzania and finds similar patterns, similar order of magnitudes as we do here. So yeah, it should be repeated at other levels of aggregation, preferably with data that allow you to, that allow you to split out what is what, right? What is going on. And Peter had some idea that even with this data we could actually take it further than we did. But yeah, this should be redone at a micro level, if at all possible. Right? And then Peter.
So this is interesting, but you're challenging two pieces of your work out in the literature. I just wonder what they did that you don't do. Is it that they've got big discontinuities that cliffs to fall off?
Burke, you mean?
Well, Burke or the Dietz.
Well, Dietz and Stern, there's no empirics in that. This is just, let's make an assumption and then let's numerically solve a growth model. Right? Burke is just embarrassing. So this is Burke, Xiang, and Miguel, Ted Miguel, and Ted should know better. They don't test for co-integration. I think they failed the co-integration test in not the usual way, but essentially, so they kill the growth pattern by dummies, and then they regress on temperature. And they made sure that the left-hand side variable is stationary. Well, they presume the left-hand side variable is stationary, probably they're right. So really what they run their regression on is on the co-integrating vector of their estimated dummies and the temperature variable. And I don't know what that means statistically, but I think it's complete nonsense. It's definitely not something that Chaponia, who's not here, would teach our people how to do time series analysis. It's completely and utterly bizarre what they do in that thing.
So could you do that on your data?
Yeah, at the risk of being taken...
No. That's exactly the point. I mean, here these guys are published in Nature now. Lots of people say, Nature, well, all right. But just to say, no, this is purely a figment of some guy, methodology would be an extremely powerful design. Not all these guys say, different data, different technique, you've got a different answer.
We being David Stern and people, David Madison and people like that, Greenstone got involved at some point. It is very easy to take the Burke paper apart. It's probably not good for your career to take the Burke paper apart, and the chance of it getting published is basically zero. These guys, I mean, an economics journal would say, okay, some idiot published something stupid in Nature, why would it publish a rebuttal? Whereas Nature would say, go fuck yourself. Right? These guys have these journals in their pockets, they would not. So the chance of getting published is very slim if they get sort of they realize that you're doing this, they would come after you in big time. Not worth it. We had a long discussion about it and we decided this is not worth it. Peter. Sorry for all the young people in the room to discourage you in this way.
So you talked about co-integration, etc., but you've got fairly modest N reasonable N and fairly modest T, right? T's going.
T is 40 something. Yeah.
So, but the asymptotics of this in reasonable N, fairly small T, are not that straightforward. So. The other thing I think is, coming back to Richard D's point about trade, etc., in some sense, this data set assumes that all of these countries are independent from one another. Okay? Now, in some sense, what we know is they're all interdependent on one another to hugely varying degrees. And that's something which you could begin to model by simply, say, taking the pattern of trade as the adjacency matrix and thinking about it accordingly.
Elsa, do you know? Did Marco try this? I don't know either. I know we talked about it.
It's not that hard to do.
No, I know. I know we talked about it. I'm not sure whether we did it or not. I need to double check. But no, it's a good point. It should be robust to spatial autocorrelation as well as temporal autocorrelation. We did test for that.
Okay, thanks. Thanks.